Hi there again. We're going to talk about heterogeneous aqueous systems. Last time we talked about, which means all the same. Heterogeneous means that the particles are not all the same. And so gelatin, jello is an example of heterogeneous. It's called a colloid. The pieces of jello, of the gelatin, are really big. And colloids and suspensions have big particles inside of them. Solutions are small. You can run a solution through a filter and not get any pieces out of it. But bigger particles be filtered out or removed. Heterogeneous aqueous system. So Kool-Aid is a good example of homogeneous. Heterogeneous is a good example of jello. So we'll move on with this. So what's the difference between a suspension and a solution? We talked about solutions in the last section. Suspension is a mixture when so when you let it sit for a while, all the little particles are going to settle to the bottom. So that's a suspension. They're pretty big particles. Gravity will pull them down. So suspension is different because the particles are much larger and will not stay in the solvent for a long time. They'll finally fall to the bottom. Suspensions are heterogeneous, and they can you can clearly identify them, and this is the suspension right here, and the particles are so big you can filter them. So here's the solvent. Here's the heterogeneous system, and we're filtering out the particles because they're so big. Colloids, how are they different? Colloids are heterogeneous, and they have particles between 1 nanometer and 1,000 nanometers. And the colloid particles are spread throughout the dispersing medium, if I could speak. So these colloids have particles smaller than suspensions and larger than those in solutions. So we have solutions smallest, colloids, and then suspensions. So that's how the particle size works. So here's some examples. Good old marshmallows and whipped cream are examples of colloidal systems. So here's some different ones. And so when we have a colloidal particles, we can see this thing called the Tyndall effect. So you see it when you drive on a foggy night and your car headlights go through it and you can actually see the beams of the headlight. That's the Tyndall effect. And so it shows us when we have a colloid. So it's used in the lab that way. So a colloid, if we have a light source, we won't be able to see the light beam through a solution. We will see it through a colloid in the suspension. Another thing we can see in colloids is something called Brownian motion. And so this botanist Robert Brown saw it in the microscope. And it's caused by collisions of molecules in the dispersion medium, if I could talk, with the small little colloid particles. So colloid system can be destroyed or coagulated by adding ions, and those charged particles will will interact with the colloidal particles and make coagulation. So you might have heard that in blood. You can coagulate blood. When the ions are added, they neutralize the charge of the colloidal particles, and the particles clump together and form aggregates and precipitate. So this can happen in blood if there's a problem chemical that gets into blood. An emulsion is a colloidal dispersion of a liquid in a liquid. So you have two liquids together, but the pieces of one liquid are pretty big. And we add this emulsifying agent to keep everything in suspension and not falling out. So mayonnaise is a heterogeneous mixture of oil and vinegar, and it would really separate fast because oil and water don't mix, so vinegar is pretty much water. If you add an egg yolk and whip it all up, it will keep these two layers together, and it'll never separate. So mayonnaise you can keep in the jar in the fridge forever, and it never separates because this egg is able to keep these both together and in one single phase instead of having two phases like that. So that's called an emulsifying agent. You'll see that a lot in foods that you eat. If you look at the packages, it'll say emulsifying agent on there, so you know there's some chemical in there keeping the layers all mixed up. So here's just some basic definitions. So this is probably a good little slide to wrap your mind around. You don't have to memorize these things, but just know that the particle sizes and things like that. So let's try this one. This quiz, here we go. So what is unique to suspensions? So what do you think? So they settle due to gravity because those particles are pretty big. Next question. Homogenized milk contains particles that do not settle. So homogenized milk is a colloid. It's got pieces, they're not as big as suspension pieces, so they don't want to settle. Tyndall effect can be seen in what two things? Alright, here you go. So colloids and suspensions show that light scattering, that you can see the beam of the light. So I hope you learned a little bit about different types of heterogeneous mixtures, and I'll talk to you soon. Bye-bye.